There are two parts to the mill. The first part that I'll talk about is the head. The head consists of the spindle forward reverse switch, the e-stop button, the RPM adjustment dial and readout, the gold box on the left side is the power drawbar in and out buttons. Next is the digital scale, the quill handle and lock. And over to the right is the Axis DRO control panel. The second part is the table and the knee. That part consists of the Z power feed and hand wheel, the Y-axis hand wheel, the table which the vise is mounted to, and the X-axis hand wheel.
Open the bottom drawer using the notch on the side. All the tools you'll be using are in this drawer, so leave it open.
Familiarize yourself with the hand wheels on the mill before you start machining. The X-axis hand wheel is located on the right side of the table. Extend the handle on the hand wheel and turn the wheel in both directions. Notice the number changing in the X on the DRO when turning the hand wheel. The Y-axis hand wheel is located on the front of the machine. Do the same with the Y-axis hand wheel as you did with the X. The Z-axis gearbox is located to the left of the Y hand wheel. It has a power feed option to go along with the hand wheel. Using the power feed saves time when moving the table up and down. To raise the table, lift up on the lever on the left side of the gearbox. Notice the number getting smaller in the Z on the DRO. To stop the feed, put the lever back in the middle where it started. To lower the table, push the lever down. Notice that the numbers are getting larger in the Z on the DRO. The Z hand wheel is generally used to make finer adjustments, such as setting the tool to the part, as you will see later in the video. Let's transition over to the DRO itself. The buttons on the DRO that you will be using are the X, Y, and Z, the numbers, and ABS set. Please do not use the arrows just to the right of the screen. The video identifies these arrows with a red box with a line through the middle of it. If you accidentally press one of the arrows and a green box appears on the screen, please notify staff. We will get you back into the proper screen. Failure to do so could result in damage to the part, the tool, and the machine, or all the above.
Clean the jaws of the caliper using a piece of paper and calibrate the caliper. Measure from the flat to the radius and write the dimension on your drawing. Use a rag and wipe the vise clean of any oil and chips. Place the rag back in the toolbox when finished. Please do not leave the rags on the machine. Place the parallel into the vise. Now place the part into the vise with the existing hole to the left and facing the solid jaw as shown. Tighten the vise and use the dead blocks to hammer the part flat on the parallel. Make sure the parallel is tight under the part. Before mounting a tool, make sure that the quill is all the way up and locked. Place the collet in the spindle by lining up the key and keyway inside the spindle. Using your thumb and index finger on your right hand, lightly hold the end mill and push the collet up. To lock the tool in, Firmly press the in button. This will activate the power drawbar. Set the quill stop approximately 1 inch from the top. Now bring the quill down to the stop and lock the quill. Now zero the digital scale. Pull up on the Z power feed lever to bring the table up so the part is within an inch of the end mill. Using the X and Y hand wheels, position the part directly underneath the end mill. The part is now in position for the touch-off phase. Turn the spindle on by turning the switch to the forward position and adjust the RPM dial until the readout reads 1000. Turn the Z hand wheel clockwise to raise the table. Raise the table until the tool lightly touches off the top of the part. Use the X hand wheel to move the part away from the tool and shut off the spindle. Press Z on the DRO, type in the diameter of the part you measured earlier. In this case, I'll enter 0.937 and press ABS set. Next, I'll raise the table by 30 thousandths, in my case, up to 0.907. Note, do not cut down more than 30 thousandths at a time. Add cutting oil to the part, turn on the spindle, use the X hand wheel to slowly feed the part all the way across the end mill. The slower the feed rate, the better the finish will be on your part. Now raise the table with the Z hand wheel until the Z reads 0.876 in the DRO. Remember, no cuts more than 30 thousandths of an inch at a time. Add more cutting oil, turn on the spindle, and use the X hand wheel to feed the material across the end mill. This flat will be wider than the end mill, so we will have to move the Y axis to remove all of the material. We can now remove the part from the vise and wipe it clean with a rag. Measure from the flat you just milled to the opposite side. You'll want to make sure your measurement is within tolerance stated on the drawing. Before starting flat 2, we'll take the parallel out, wipe it clean with a rag, then we'll wipe the vise clean and insert the parallel back into the vise. Place the part inside the vise, putting the flat with the existing hole facing the parallel and the hole still oriented to your left. Secure the part in the vise and use the dead blow to firmly tap the part until the parallel is tight under the part. Use the Z hand wheel to lower the table until the DRO reads approximately 0.94 in the Z axis. Turn on the spindle and use the X and Y hand wheels to position the part under the end mill. Raise the table using the Z hand wheel until the end mill lightly touches the part. Now move the part away from the end mill. The DRO and the Z-axis should read close to what you set the first flat at. In my case, 0.937. Add cutting oil to the part. Move the Z-axis hand wheel until the DRO and the Z is at 0.906. With cutting oil and the spindle on, use the X hand wheel to slowly feed the part all the way across the end mill. The slower the feed rate, the better the finish will be on your part. Add more cutting oil and use the Z hand wheel to raise the table until the Z reads 0.876 in the DRO. Remember, no more than 30 thousandths of an inch at one time. After removing all the material, move the part away from the end mill and shut off the spindle.
If the measurement is within tolerance, raise the quill and lower the table. Lower the table to give yourself plenty of room for the keyless chuck, the drill, and the tap. Once you have about 6 inches of space, stop the table. Make sure the quill is all the way up and locked. With a rag in your hand, hold it below the end mill and firmly press the out button. Load the keyless chuck by aligning it in the spindle and firmly pressing the in button. Now tighten the edge finder into the keyless chuck as shown. Lower the quill stop to give yourself enough room. First, we'll find X0 on the left edge. Bring the quill down so the edge finder is just below the fixed jaw. Turn on the spindle and adjust the RPM to 800. Use the X hand wheel to bring the part closer to the edge finder. The edge finder will start to straighten out, but don't stop there. Now the edge finder is starting to straighten out. Continue going until the edge finder just barely breaks. This is what it should look like when you set your X0. Press X on the DRO, followed by ABS set. Back away the edge finder and repeat this step to make sure you're consistent. Unlock the quill and raise the edge finder out of the way. To set our 0 at the center of the chuck, we must adjust for the radius of the edge finder. The radius on this edge finder is 0.25, so move over in the X direction to positive 0.25 and re-zero the X. You should be able to see that the center of the chuck lines up with the edge of your part. To find Y0, we will use the fixed jaw of the vise. Bring the quill back down and lock it into place. Turn on the spindle and use the edge finder the same way, but in the Y direction. Here the edge finder is starting to straighten out, and as it breaks, we will stop and zero the Y there. There it breaks, so we will zero here. Press Y on the DRO, followed by ABS set to 0. Reset the edge finder and do this again to ensure for consistency. Just like with the X-axis, we must lift the edge finder out of the way and adjust for the radius of the edge finder. After moving to positive 0.25, re-zero the Y-axis. Should be able to visibly see the center of the chuck is in line with the back jaw. Load the spot drill into the keyless chuck. Bring the spot drill down till it touches the top of the part. And zero the quill readout. Turn on the spindle and adjust the speed to 1000 RPM. Use the spot drill to a depth of 50 thousandths of an inch. Now remove the spot drill and put it back in the toolbox. Grab the drill and push it all the way up into the keyless chuck and tighten it down. Touch the drill to where you just spot drilled and zero the quill readout. Add some oil before drilling. With an up and down motion, peck drill the part until you reach negative 0.7. Remove the drill and put it back in the toolbox. Grab the countersink and load it into the chuck. For the countersink, lower the RPM to about 300. Use the countersink to create a chamfer around the hole. Remove the countersink and put it back in the toolbox. Grab the dead center from the toolbox and load it into the chuck. The tap has a square end while the handle has V-jaws. Fit the corners of the square into the V's in the handle. Turn clockwise to tighten down. Place the tap into your drilled hole and bring down the quill so the dead center fits into the top of the handle. Lock down the quill. Before tapping, add some cutting oil. While tapping, we will turn it 3 half turns forward and 1 half turn backwards. This will break the chips and prevent the tap from breaking. Continue making 3 half turns forward and 1 back until the tap reaches the bottom of the hole. You will know you reached the bottom when it gets difficult to turn. Once the tap hits the bottom, raise the quill and unscrew the tap. With the rag covering the hole, blow out the hole to remove any chips. If everything is done correctly, the thread checker, as shown in the video, should screw down so that the nut is flush with the face. Use the file in the forward direction to remove any sharp edges. Once completed, take all the measurements and fill out the part drawing.